Hi guys, so you guys are going to do task 2.9, can you get to the point 2, which is on page 49 of your module. This is a solidifying understanding test, so things should kind of start coming together here. We're going to do a couple solidifying understanding tasks in a row. This is kind of the beginning of it. We're actually going to essentially be redoing task 2.8. If you recall, in task 2.8, it was about Carlos going shopping, and you had to figure out the prices of all the items he bought. And I asked you, and I told you that you could not use equations. Okay, equations were not allowed. Well, in task 2.9, you're going to be going through those same problems that you already did, but this time you have to use equations. Okay, so you're going to need to write these as equations, and I'm going to ask you to solve it algebraically. The only thing is, I don't want you to solve it using the substitution method. I want you to solve it in the same way you kind of solved the ones you did in 2.8, but without the equations. I want you to solve in that same method. So I don't want to see you converting these equations into y equals and substituting in. Okay, that's our substitution method. We're going to work on a new method now. Okay, develop from what you did on task 2.8. So, you should have realized that from task 2.8, okay, you should have come up with the fact that, text, you should have come up with some strategies already, okay. So you should have come up with that if the number of one type of item is the same in both purchases, then the difference in total cost is due to the difference in the number of the second items purchased. So if he was buying the same number of Figaro Flakes, if he was buying the same number of Tabitha Tidbits but a different number of Figaro Flakes, then you know that change in price is due to the fact that there's a different number of Figaro Flakes. Okay? You also know that if we know the total cost of a combination of two items, we know the total cost of buying twice as much. So like if I bag or 3 times as much. So if I buy 2 bags of Brutus Bites and 3 bags of Lucky Licks, and that's $42.50. If I double everything, if I buy, instead of 2 bags of Brutus Bites, I buy 4 bags of Brutus Bites. Instead of buying 3 bags of Lucky Licks, I buy 6 bags of Lucky Licks. Since I've doubled both of those, I know I'm just going to have to double how much I paid. Okay, so that's a fact. And if I triple, same thing, I triple it. Okay, so I can do that to any of them. I can double and I can triple equations. I can half equations. I can cut everything in half. Okay, but I got to do the whole thing. We also know that 2 different combinations of the same items can be added together or purchased at the same time. So if I purchased 4 bags of Brutus Bites and 3 bags of Lucky Licks and 6 bags of Lucky Licks, and then I purchased 5 bags of Brutus Bites and 6 bags of Lucky Licks, I can add all that together or subtract it from each other. So I can add it all together, and I know I'd have to add the costs as well. Okay, that's all it's saying. If I add those 2 combinations, I got to add the costs as well. And that makes sense. Okay, so that's all these say. I would suggest pausing the video at this time so that you guys have an opportunity to write this down. I'm going to put some spacing in here so it's just a little bit easier to write down. Okay, so hopefully you're paused the video because I'm just going to keep going here. Okay, so pause the video as needed. Okay. So, your job is to write a system of equations that represents these purchases. Okay, I want you to write a system of equations to represent the purchases. And I want you to show the strategies for finding the cost of the individual items by manipulating equations. Okay, and again, not through substitution. I want you to show me all steps so that I could look at it or someone else could look at it and follow your work. So please don't skip steps. And keep in mind, once you find the price of one item, you gotta find the price of the other item. Okay, we need the price of both. Now, since you've already done this, I'm just gonna be giving you the answers for the cost so that when you've done the work algebraically, you're going to know that you did it right. Okay, so I'm not really worried about that. But remember, you still have to write equations and you still have to solve them. And I want you solving in the same logical thought process that you solve them in 2.8. So think about your reasoning that you wrote down. I want you doing the same thing here, but a little more algebraically now, okay? So Tabitha Tidbits, those are $7. And Figaro Flakes, you should have gotten were $5.50. Okay. Then on number 2, Brutus Bites, they were $9.25. And Lucky Licks, they were $8. So pause as you need so you can write these down, maybe small in the corner so you have lots of room for work. Then we have dog leashes. We should have figured out were $4. And cat brushes, which you should have figured out was $3.50. Remind me to tell you the time of when I had a cat on a leash. That's a funny story. Okay. So, next one, we're looking at dog bones and cat treats. So, dog bones, you should have found were $4.25. And cat treats, you should have found were $2.50. And then our last one was small bags of cat food and dog food. You should have found that cat food was $3 and dog food was $2.75. Okay, so again, pause as you need. Okay, so I should see you doing this in the same method you used in 2.8, but this time you're showing me algebraically those methods. Okay, you're showing it to me algebraically, so you need those equations. Okay, algebraically does not mean showing me the arithmetic. It means I should have equations and variables and I'm manipulating those equations. Okay, so that's what I should see here. And again, you're not solving an equation for y and substituting in. You are using your same method that you used in 2.8. Okay, so look back at your reasoning. Once you finish part 1, it asks you to graph each of those scenarios so you can see where those intersect. I'm going to actually have you do part 2 after part 3. So I want you to skip down here. And you're going to be, the method that you've been using above is called the elimination of variables method. So I'm going to ask that you now use that same method, but this time you're going to be using it with our startup and space constraints and our pampering and feeding time. So I'm just going to give you those constraints here, give you those equations that we wrote. So 6y plus 24x equals 360. And then we had 32y plus 80x equals 1,280. Okay, and I'll label these. Oops. I'll do it over it. So this is my startup. Oh, this is my space. This is my space. And this is my startup. Okay. And then I'm also going to give you the pampering and feeding. So here's feeding. It's 12y plus 20x equals 480. And then we have pampering. And that should come out to 16y plus 20x equals 480. Move this one here a little bit. And I'd like just to remind you really quick, our x was equal to our number of dogs, and our y was equal to our number of cats, okay? So, I want you to solve these again using that elimination method, okay? Using those, using our reasoning here, our key strategies. Using our key strategies here from 2.8. Okay, shopping for cats and dogs. So, please make sure that you are going through